Plinian column. For Pompeii, this cloud was lethal. The pumice and ash was carried by the prevailing wind to fall like a deadly gray snow on the ancient city.
And it was this volcanic fallout that started to thicken the air. The people who were initially amazed by the volcanic eruption now started to find it difficult to breathe.
Many of the victims of Pompeii suffocated on the fine ash.
We see a picture of people struggling to breathe, like this body here, which is curled up with their hands close to their face, essentially recording the last final breaths of the people as they filled up with ash and hot, fiery dust from the volcano.
Such a rain of ash falling onto the crowded streets of Naples today would cause millions of casualties. In trying to solve the mystery of what makes Vesuvius the most dangerous volcano in the world, scientists have uncovered two crucial pieces of evidence. The pumice from Pompeii proves that Vesuvius can produce explosive eruptions, the most devastating type of volcanic blast. A thick layer of volcanic ash found underneath Naples shows that Vesuvius has the power to stretch out and destroy the city. A similar-sized blast today could kill 3 million people, which would be the world's highest volcanic death toll. Geologists know that some victims would die of suffocation, but the discovery of charred human bones are clues to another, more terrifying death wrought by Vesuvius. Geologists are investigating the deadly threat of Mount Vesuvius. Remains at the Roman settlement of Pompeii show how thousands died, buried by a choking rain of ash and rock. But in 1981, excavations 4 miles to the west of Vesuvius showed that an even more horrific fate awaited the people of this Roman town: Herculaneum. When the volcano erupted in the year 79 AD, Herculaneum was a busy resort town of 10,000 people. But surprisingly, when the ruins were first excavated, a mere 15 bodies were found.
And many people thought that that was because they could see the eruption early on and were able to escape. But when they dug down further, here to the shoreline and to these boathouses, this is where they found the truth.
The boathouses hid a grisly secret. These are the remains of the Romans caught trying to flee the volcano. The skeletons still lie exactly where they fell 2,000 years ago.
It's hard to imagine what it must have been like. Over 300 men, women and children here at the water's edge in Herculaneum. Here the boathouses providing shelter from the falling volcanic debris. And it was these boathouses that were going to become the final resting place of their tomb in Herculaneum.
For geologist Dr. Jerem, these remains hold the primary clue to exactly what happened during the eruption 2,000 years ago. The mass grave is treated like a crime scene. Photographic evidence is taken back to the laboratory for further investigation. The positions of the bodies themselves are the first clue to how quickly a volcano can kill.
Here we have a body that sat up against the boathouse wall in Herculaneum, and in the arms of this adult is a child. And they're sat there almost as though they were relaxing or resting against the wall. It's almost as though you could be sat there chatting with this person, and then they've been killed.
There are further clues to be found in the fine detail of the victim's bones.
At the end of many of the bones, you see this blackened coloration. And this can be seen on many of the examples in Herculaneum. And it really seems to occur at the points, like here at a sort of elbow joint, the points on the body where there's very little flesh, and the bone is very, very close to the surface.
For years, scientists debated what the discoloration could mean. Until in 1991, researchers from the University of Naples came up with a simple solution.
I'm going to recreate the one experiment that unlocked what happened at Herculaneum.
Dr. Jerem is burning several pig bones at increasingly superheated temperatures.
I'm going to rack up the temperatures, start to try and burn the flesh on the bones, and then hopefully get to the point where I can start to produce blackening of the bones and reproduce the colors that we see in the Herculaneum bone deposits.
Dr. Jerem burns one bone at 500 degrees and another at 700 degrees Fahrenheit.
The flesh is all starting to burn now, but clearly we're not really burning the bone here.
It is not until Dr. Jerem raises the temperature to 900 degrees that the bone itself is burnt.
Well, it finally looks like we've got somewhere where we're starting to burn the bone.
Scraping away the charred meat and skin reveals the bone underneath.
Here on this picture from Herculaneum, you can see on the end of this bone these brown into black transitions with some nice white bone behind. You know, this is exactly what we're seeing in the 900-degree experiment. So we can produce the blackened bone features that we see at Herculaneum with high temperatures, burning the bone that's exposed, but the bone that's covered by a bit of flesh gets protected and stays white. And this could be the only way in which we get these blackened bone features at Herculaneum.
The blackened bones show that on the day of the eruption, the air temperature 4 miles from the volcano reached 900 degrees Fahrenheit. That's hotter than the blast from an aircraft's jet engine. For years, scientists puzzled over how Vesuvius could have raised temperatures so high, miles from the volcano. But then, a totally different type of clue suggested the answer. At the small town of Boscoreale, just 1 mile southeast of Vesuvius.
This strange pillar-like structure, I mean, at first impression, it looks like some very strange, weird concrete post. But it's far more fascinating than that. And the clues are really in the base. We see a number of smaller structures radiating from the base. And these are actually roots. You see them feeding back into this big stump-like feature. This is a fossilized tree.
The tree was buried in volcanic material. As the original wood rotted away, it was replaced by rock and ash, which mixed with water and set like concrete.
Almost like a jello mold of a tree upstanding that was upstanding over 2,000 years ago.
The shape of the tree is deeply significant.
And as we work up this fossilized tree, it suddenly veers and bends at this point here. Now, if we can imagine, about 2,000 years ago, this tree was alive. And suddenly it's been wrenched over and bent towards that way, and it's also been fossilized in that position. Now, when we look at the local geography, we know that Vesuvius is over that way. So some force which is bending this tree and fossilizing it must have been coming from that region.
The clues of superheated temperatures miles from the volcano and a force that bent a tree almost double suggest only one thing. They're evidence that Vesuvius produced another deadly weapon. A pyroclastic flow.
Pyroclastic flows are a dynamic mixture of hot rock, ash and gases that move fast and violently down the side of a volcanic mountain.
These deadly boiling clouds reach speeds of up to 450 miles per hour, faster than a bullet train, and temperatures of up to 2,000 degrees Fahrenheit, hot enough to melt gold.
At the early stages of the eruption here at Herculaneum, you would have seen a big eruptive cloud coming out of Vesuvius and heading off up into the atmosphere. But just imagine how scared you would have been watching this cloud suddenly turn round and the black cloud starts heading towards Herculaneum. This cloud of hot material,
hot, boiling, bubbling pyroclastic material starts to enter the city streets, starts enveloping you and heading off down towards the port. And that was it. The pyroclastic flows had hit Herculaneum.
Just hours later, the town was buried completely. Striving to understand how deadly Vesuvius can be, investigators have found vital clues to the devastation from the searing heat of pyroclastic flows of the past. Horrific burns on human bones prove temperatures got to a blazing 900 degrees Fahrenheit, 4 miles from the volcano. And a 2,000-year-old fossilized tree reveals the power of the speeding flow of hot rock, gas, and ash down the mountainside.